In this video, we're looking at LeetCode 17, letter combinations of a phone number. Problem statement says, given a string containing digits from 2 to 9 inclusive, return all possible letter combinations that the number could represent. And so you have a mapping of digit to letters, just like on the telephone buttons as shown below. And they're saying you can see that the number 1 does not map to any letters at all. So if they give you 2, 3, you can see on 2 it has A, B, and C, and on 3 it has D, E, and F. And so you could have A, D, A, E, A, F, B, D, B, E, B, F, C, D, C, E, and C, F. So that's the output that they give here. And I've gone ahead and added a mapping here where the key is just the numbers 2 through 9 inclusive, and then the value is the array of letters on each key, just to get that boilerplate out of the way. So we have the numbers 2 and 3, and that maps to A, B, C, D, E, and F. We can use recursion to model arbitrarily nested loops. And so the first loop, we have 2, and we have A, and we have B, and we have C. So we'll have a loop that goes through each of the letters that that number could represent. Then inside of this loop, after it plants a number, let's just say A, it's going to recursively call itself and explore the next number. So there's going to be this recursive function call where we're exploring for 3. And we see that it could be D, it could be E, and it could be F. Then the stack will unwind and we'll get to the next iteration of the first loop where we delete the A and plant the B instead for the first digit, and then make a recursive call. And in this recursive call, we'll do D, E, and F planted in the second digit again. Then it'll unwind and do the same thing here. D, E, and F. And now, let's say there was a 4 here and a 5, and there was, more letters here. It doesn't matter because if you can think about this one recursive call, you can just say, okay, this is going to be nested arbitrarily deep, right? All we need to think about is this one step. We only need to think about this. Because if we go from one digit to the next, we can also go from this digit to the next digit, and we can go from that digit to the next digit. So we only need to think about this one leap, and then just know that it's done recursively. Okay, so to code this, I'm going to use a helper function, and I'm going to have some combos stored in an array. We're going to pass in the digits, some temporary path array that we can mutate, and then the combos array, and then we're going to return the combos at the end. And then for my helper function, it's going to take in the digits, path, and the combos. And then we're going to have a base case. So if the digits.length is equal to the path.length, then push that path into the combos and then return, so that because it's a base case, we don't want it to proceed. And then we want to look at the current digit, which is going to be digits.substring. So if it was the first digit, it'd be 0, 1. So start at the 0th index and then take one character. But in the second iteration, we want to look at the second character. So we'll look at the path length, because in the second call, we'll have one thing in the path already. If it's the first call, there'll be nothing in the paths, and we'll take from index 0. We'll do for let char of map of that digit, and what we'll do is put on path recurse remove from path. Okay, so putting it on the path is just it's a string, so we'll take the path itself and put the digit or the character at the end, and then to remove it from the path, we'll take the path and reassign it to the path from the first character up until the n minus 1. And then for the recursion, we call the helper with the digits, the path, and the combos. We'll go ahead and run that. And submit. So the mistake here is because I passed an array for the initial path, but then I treated it as a string. Because JavaScript is not typed, that just kind of coerced that array into a string in some cases, but kept it as an array in other cases, which is why you should probably consider using something like TypeScript to type your code and catch these errors before your program is out in the field running with real users, or before you've submitted your answer. So anyways, if we fix this and make it a string instead of an array for the empty path, that should fix the edge case here. And it looks like we're still returning an empty string here. And so we can just explicitly handle this edge case and say if the digits.length is equal to 0, then just return an empty array, and that should fix it. So that's how you do the letter combinations of a phone number on LeetCode using JavaScript. All right, thanks for watching.